Let's talk a little bit about how inheritance actually works under the covers. To do that, I want to start with this class parent that I'm showing right now. So I have a class parent, and one of the things that we've learned is that you can make classes that inherit from that. For example, I can make a class A that inherits from parent. I have the option of redefining a method, so I'm going to redefine the spam method. And then there's this super function that you might see somebody using to kind of call the parent. So you can make a class that inherits from another class. What's going to happen with that is if I run that code, I can say A is equal to A. If I were to say A.spam, you would see it call A.spam, and then you would say parent.spam. And you can continue this, with other classes. Like I could say class B inherits from A. It could redefine a method. Maybe I'll do B.spam. It could use the super function the same way. If I try to use that code, like I make a B object, what you would do is you would see those methods kind of chain up. What's happening is we come in here, we print B, we go to the parent, which is a B, which is A, and then we print that, and then we work our way up the chain there. How this is put together under the covers is it turns out that every class actually keeps a record of its parents, if you will, in an attribute called MRO, short for method resolution order. If I look at B and I look at its MRO, it comes back and it says, I'm B, and then I have A as a parent, and then parent is the parent of A, and then you have object. What this is kind of describing your chain of ancestors, if you will. So whenever Python tries to fire methods, it turns out that it works its way up that chain. This is the idea on simple inheritance, is that every class will kind of keep a record of who its parents are. And then when you're looking at attributes, it will walk this chain left to right, looking for a match. This is what's going on under the covers. Now, where things start to get interesting is if you start dealing with things like multiple inheritance. I'm going to make a class C that inherits from parent. Okay, C.spam, and I'm going to have it do the same thing. So I'm going to have class C, and I'm going to have a class D, again, that implements the same functionality. Okay, so we're going to have a bunch of classes that all define the spam method. What I'm going to talk about next is what happens when you start merging these classes together. So let's say you have these different classes. Like I have a class A, where if you call spam, you get A.spam, parent.spam. I have a class C, where if you call C, you get the same thing, C.spam, parent.spam. The same thing happens for this D class. You have these three classes up above. They all have the same parent. They all have a method spam on there. Here's something interesting that happens if you start combining these classes. I'm going to make a class E that inherits from A, C, and D all at the same time. Okay, so this is multiple inheritance. And I'm going to look at what happens if you call the spam method on this. So let's say you say E.spam. The amazing thing that happens here is that all of those methods will fire in a chain. You'll see it go A.spam, C.spam, D.spam, and then parent. It's like they lined up in a row doing that. If I change the order, like let's say I have a class F that decides to do the classes in a different order, you'll find that they line up in that order on that object. So what's happening is you have like D.spam, C.spam, A.spam. What you're seeing here is something known as cooperative multiple inheritance. Essentially, Python, when it does inheritance, follows two rules. And the two rules are really this. Any child class always needs to be checked before its parent. That was actually what was happening in kind of the first part of the code. It was like you were seeing these chain of child working its way up through its parents. But there's a second rule that says if you have more than one parent, the parents have to be checked in order, meaning that you're going to check D first and then C and then A. And it turns out that with those two rules, if you have more than one parent and all of those share like a common ancestor, they will kind of line up in the order that you list there. It turns out that this is actually a technique that is used to do, like composition of classes, essentially. Like you could have like different classes that implement some kind of like functionality that gets mixed with another class. You can essentially control the order in which these things kind of link together or compose together. It's a very kind of interesting technique to play with. It's the basis of doing things like mix-in classes in Python. Just to see that under the covers, by the way, if you were to look at the MRO of this F, you actually see those classes kind of line up one after the other. or if you look at the MRO of E, you see them kind of line up in the order that they were listed there. One final comment about this. The super function in Python is actually not well understood, to be honest. What that super function does is it essentially moves to the next class in this MRO chain. So like if you're in this class C and you do super, what happens is Python will find the location of the C class on this list, and then it just moves to the next class over. So it would continue on with A and then parent. A little bit of detail under the covers about how inheritance works. It's got two directions. Essentially, you go from parent to child is one of the rules. But then if you have multiple parents, the parents get checked in order.